I really went with maximizing the number of AI-related keywords I could in the title, trying to optimize the Twitter results. Maybe I'll get a few hits. We'll see. So I just kind of want to jump into it. I'm going to introduce myself properly in a minute, but before I do that, I just kind of want to tell you a story to kind of get us all on the same page. So a few years ago, I was at the Colorado School of Mines, which is in Golden, and I was taking a computer science class. And in this class, the professor was telling us about a common trade-off that shows up in software. And the way he phrased it, he said it was a rule and not like really like a heuristic or anything. He said it was a rule. And he said, there are 3 things that you can have in software, but generally, only 2 of them can be true at any given time. So those 3 things are, software can be good, it can be fast, or it can be reliable. But it can only, like I said, it can only really be 2 of these things at once. So it can be good and reliable, but maybe not fast. It can be fast and reliable, maybe not good. Or it can be, what's the last combination? Good and reliable, but not fast? Whatever. You get my point. And I was thinking about this, like he was telling us this in class, and at the time I was actually maintaining a WordPress site, and I knew for a fact that there was software that doesn't fulfill his rule. That there is software, especially open source software, that is good, and it is fast, and it is reliable. And I thought about it some more, and I noticed that of all the software that I used, there was software that fit his criteria, but the vast majority of the software that didn't fit his criteria was open source. So what I want to talk about today is I want to talk about how these 3 things can be addressed using machine learning, how we can improve the quality of our software without sacrificing speed or reliability, and how we can do that in an open source project, and how a lot of the kind of prevailing theory on how to build machine learning into software is kind of counterproductive. So I've already talked about the 3 things. I want to take a brief tangent into kind of like the recent developments and investment into AI infrastructure. Then I want to talk about myself for a little bit and what I do at Automatic. And then we're going to go through kind of a case study on how we can improve the quality of our software with ML without sacrificing speed or reliability. And then if we have time at the end, we'll take some questions. So hold on to those. So I was in a different class. This one must have been an English class because I was sitting next to 2 students that were talking about ChatGPT. And they were really excited, I remember, because when you first sit down with ChatGPT, especially around 2023 it must have been, it was a huge wow moment. People were really, really excited about the idea of talking to a computer. The fact that you could have a conversation or feel like you're having a conversation with a computer, it was very, very exciting. And the students in the English class were especially excited because they wanted to cheat on their homework. I would never do such a thing. But I sat down after I heard them talking about it, and I tried it out, and it was very exciting. And since then, I've been kind of getting more and more into the field and exploring the possibilities. And I've noticed that large language models are one of the chief examples of the kind of law that the professor was originally talking about. You can either have small models that are maybe not very useful, but they're fast and I guess they're all kind of reliable. Or you can have a much bigger model that is good, but kind of slow. And it has the same reliability as the smaller models. It's kind of universal. And AI companies know about this, right? They are very well aware of this trade-off that is kind of naturally coming about. And as a result, they're investing enormous amounts of capital into infrastructure for training and running these models at scale. And there's been a lot of news about this lately, but I'm just kind of curious. This is going to be one of those exercises where you have to raise your hand. How many of you guys think that that the US economy has spent more than $1 billion in the last 8 months on AI infrastructure? Okay, that feels right. That's a good baseline. How many of you guys think it's more than $5 billion? Okay, not quite as many hands. 10? Oh, 50. I see one hand. We've actually spent $100 billion on building new infrastructure in the last 8 months alone. If you add up the numbers since 2023, for data centers that are specifically meant for training and running inference on these large language models, we've spent over $500 billion. But this $100 billion is actually a really startling number because that's more than, so the US is the biggest consumer economy in the world. That's more than we've spent on all shopping combined. All Amazon purchases, all Target purchases, all Walmart, all grocery stores, all malls, all of that combined is less than this number. All of it. So it's a lot of money. They're trying very hard to address this problem. But I want to make the case today that for the vast majority of applications where you want to integrate machine learning, you don't need anywhere near this level of capital expenditure, or even any capital expenditure. So who am I? I'm Elijah. I would consider myself an AI optimist. I don't think that necessarily means that we have to solve everything with an LLM, though. I think that's a pretty universal opinion. Like I said, I'm from Colorado, and I spend a lot of time in the mountains. I find that kind of tromping around in the wilderness is a really great way to clear your head so that you can attack problems with a fresh perspective. I really don't like bullet points on slide decks. I think they're excessive. There's one other slide with bullet points, though. It's very hard. And then I'm also a software engineer under Automatic AI. And under Automatic AI, I work on an open source project. They mentioned it before I came up, called Harper. It's a grammar checker designed from the ground up to respect your privacy. So most of the grammar checkers out there, Grammarly or a language tool, they send everything you write off to some server somewhere doing God knows what with your data. And for a lot of industries, that's a big problem. So like healthcare, that's a no-go. FERPA compliance, also a no-go. Defense, or even just any company that cares about intellectual property theft. Just yesterday, actually, or maybe 2 days ago, I was talking to an Oracle engineer, and he was telling me how the entire company just has a blanket ban on Grammarly. And that's because they're worried about intellectual property theft. So Harper is a grammar checker that kind of fulfills that niche of being entirely private. And we recently completed a project that kind of demonstrates that this idea of getting fast, good, and reliable software, it is possible with machine learning. And so I kind of want to give you an example of that. So Harper is a grammar checker, and so our job is to look at sentences with grammatical errors, locate that error, and then provide a suggestion to fix it. Now, we can't be 100% accurate all the time, but we do our best. Can anyone see the grammatical error in this sentence? Do you want to, what is it?
So bottles should be plural.
Yeah. Why?
Why?
Yeah.
Because neither implies that there's more than one bottle.
Exactly. Yes.
But there is another solution.
Which is?
Get rid of neither big blue bottle.
Yeah. 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 No, that's actually a really good point. So a lot of grammatical problems can be solved in more than one way. Yeah. And we want to be able to provide all of the options.
If they answer, we just have to say it again or use the mic.
Oh, okay. Sorry. And we want to provide all the options because it's very hard for us to know with 100% certainty what the user wants. Another way we could look at this is there are multiple ways of, we want to add an S to the sentence. That's one of our suggestions. But where do we add the S? We could say neither of the Big's blue bottle. That also doesn't make sense, but we need to know which one makes sense. Or the Big Blues bottle, or Big Blue bottles. Yeah, so we want to add it to the end of that nominal phrase. That's what we call them. We call them nominal phrases. We want to identify the nominal phrase, and we want to add our S to the end of that nominal phrase. So the problem that we're tackling right now is we want to be able to identify these nominal phrases in sentences. Sounds simple, and it's easy for a human to do, but we want to train a model to do that automatically. And we want that model to be fast. And in our case, we want that model to be very small because we want to be able to run the model on the user's device. So Harper runs on the user's device no matter what. Even if you're using it in the browser or it's being loaded as part of a web page, it's always running on the user's device, not a server. So we want our model to be very small. We had previously used decision trees for this task, but it didn't get very good results. So this project was kind of born out of a desire to get better accuracy. I just want to do a brief shout out. So for this project, we are using a machine learning toolkit called Burn. It's somewhat similar to PyTorch, if you've heard of it. PyTorch is the framework that companies like OpenAI use at huge scale. And they're building very, very big models with complex hardware requirements. We don't have as complex requirements, so we went for a framework that is intentionally small, simple, and easy for contributors to use. So like I said, Harper is an open source project. We don't want them to have to go through the rigmarole of setting up their hardware to work with our machine learning framework. When we actually did this, when we added Burn to our project and we started using it, our contributors did not notice. Like they just downloaded the code as they did a git pull. They recompiled it, and everything was exactly the way it was before. They didn't have to set up any hardware or anything like that. It also gives the advantage, so Harper is written in Rust. Burn is also written in Rust, so we can use the same language and same kind of build pipeline as we've always been using. It's also entirely portable. If we ever wanted to, we could run Burn without an allocator. So we could run it on a tiny microcontroller that has 256 kilobytes of RAM. That's possible. Okay, sorry. The other question is like, why would we want to build our own? So this is a model that we're building for the purpose of identifying nominal phrases and sentences. We are not the first people to do this. These models exist in the world already, but they're much bigger than what we want, much chunkier. And then the ability to train our own, the know-how of how the model works, how it's architected, and how we can make changes to that model is really valuable if we ever want to improve its abilities or increase the amount of information we can get from the model. Okay, so for the nerds in the audience, I kind of want to talk about the architecture. If you are not like really into the machine learning space, you're welcome to zone out for a second. This will just take a second. So what we do, our pipeline is generally, so Harper is given raw text. We want to identify the errors in that raw text. The first step is we break it down into its individual component parts. So we take each word and we identify what its part of speech is. So Harry, that's a proper noun. Walked down 4 blocks. That's a verb, adverb, number, and another noun. This is important because knowing the part of speech is just really, really valuable information, and it's very cheap to compute. Very, very cheap to compute. This step takes probably 2% of the total runtime of Harper. It's very fast. Yeah. So we take, ignore that. So we take that data, we embed the parts of speech, and we embed the words, and then we put both of those into a ByLSTM. I might get to why we used a ByLSTM for this and not a transformer later, but we'll see. We'll see if we have time. And then finally, we pipe the output of that ByLSTM through a linear layer to get our final result. And with that, our first training run, we were able to get 90% accuracy, which sounds good. That's an A, right? That sounds pretty good. No, that's pretty bad, actually. 90% is like trash in this space. The data set we're using, it's got some inconsistencies. The best you can get with the data set seems to be around 96% accuracy. That's our target. We want to get 96%. And so we did a little bit more experimentation. We tried just disabling parts of the model while we were training it, just shutting the whole thing off. The equivalent of cutting out someone's brain while they're trying to learn math. And we were actually able to get better results. So this is actually a standard technique. It's called dropout regularization. And we were able to get 95% accuracy with this model. That's not perfect. Obviously, we would like 96%, right? Because that's ideal. But it's pretty good with the number of parameters we're using and the speed we're trying to target. So we were able to get 95% accuracy with just 250,000 parameters. For context, that's 1/4 of a megabyte if we use 1-bit quantization. For context, most large language models are measured in gigabytes or terabytes. So this is much, much, much smaller. And also the runtime is less than 10 milliseconds. For Harper as a whole, we target less than 16 milliseconds for the entire pipeline so that we can give you your results in less than a single frame refresh. This only takes 10 milliseconds of that pipeline. And like I said, we get 95% accuracy on our test data. For context, if we were to use an LLM for this task, it would take several seconds and gigabytes of memory, and possibly a network connection if it's a really big model. So let's just step back and reflect. So with this model, we were pretty good, 95%. Could be better, and we're going to work to make it better in the future. We were able to improve the overall grammar checking experience with this. So I would say the good is a check mark. Fast, I don't know about you, but 10 milliseconds is pretty fast. Definitely faster than me. And then it's reliable. Because it runs on the user's device, we don't need a network connection. We don't need the internet. We don't have to worry about infrastructure going down. It's going to work always. Okay. I keep blowing on the mic. I'm sorry, y'all. Yeah, okay. Does anybody have any questions? Any thoughts? I'd love to hear it if you do.
So how do we download it onto our computers, like for math?
Yeah, that's a good, I should have mentioned that. They were like, this isn't supposed to be a sponsored talk, so like, don't advertise too much, guys. On our last slide, I can put it up now, actually. We have our website, writewithharper.com. From there, you'll find links for our Chrome extension. We also have support for Obsidian, Firefox. When you get on stage, everything blanks. Also, a huge number of our user base, because we really care about being private, you know, and companies hate sending their code anywhere. A lot of people who use Harper use it to check the comments in their code. So if you're like a plugin developer or something, Harper supports checking the comments in your code. So we have support for VS Code, Zed, NeoVim if you're into that, Emacs. Yeah. Is there? I think that's everything. Yeah, let's hear it.
Is that fixing grammar or code issues with code?
Grammar, like English grammar. So
English grammar. Okay.
what we see a lot, so especially with languages like Rust or JavaDoc or JSDoc, a lot of the comments in your code actually ends up as part of your public documentation, or even as part of a website. And so having improper grammar can actually, it can impact your search results, it can impact the experience of people consuming your code, especially if you don't have like the clarity people expect.
And if it's a Firefox extension, that's JavaScript. If it's OpenOffice extension, that's like Java, I think. If it's Office, it's probably C# or something. How does it work being a Rust, how does it work putting Rust into those environments?
So for anytime Harper's running in the web, so that's our Chrome extension, our Firefox extension, or our WordPress plugin, anytime it's running in the web, we compile Rust to WebAssembly, and we just run it straight in the browser right there. So that's nice and quick and fast, and actually it's pretty easy on our end. We don't actually support LibreOffice right now, but for other editors like Obsidian, or actually no, Obsidian's also web. For other editors like VS Code, we run a separate server, and we connect to it from whatever the native language is.
Oh, local server?
Yeah.
Okay. Thanks.
Yeah.
I had a question about the whole tokenization thing. It's great that you're able to do it so fast, but is part of it because only English is currently supported that you're able to kind of encapsulate like 3 as a number into whatever model that you're training with? Is it possible to expand this to multilingual, or will we need like multiple models for different languages?
It depends. So Harper right now is really, really optimized for Indo-European languages. So these are languages with specific ratios of like characters to words, and so we're able to perform certain optimizations there. So I don't see so to answer your question directly, our models are specific to English, yes. But certain things like identifying words as numbers, that's more general purpose and really easy to hot plug. The other advantage of having models that are intentionally so small is that they're very, very fast to train, and we can use relatively small amounts of data, which is pretty easy to find in the public domain. So when we choose to expand to other languages, the actual cost of training these models is very low. The bigger concern is things like internationalization and like just making sure we identify the common grammatical rules in that language. Yeah.
Hello.
Hi.
Wow, this is scary.
Now you know how I feel.
So, fair enough. So I have a job that prioritizes being able to respond as quickly as possible and, of course, as accurately as possible.
Right.
A lot of what you've discussed is having accurate prompts for us to be like, yes, I did misspell that word or do this grammar. The grammar could be improved, and then you select that.
Yeah.
Is there a version in the future where, especially for, you're typing super fast and you keep spelling words like appropriately, which just have way too many letters in it, incorrectly, is there a version in the future where the program can just fix that for you so you don't have to confirm, especially for things like exactly the word I'm trying to say. I just put
Right.
the P's in the wrong place.
Right. I think it's a great idea. Just autocorrect, basically.
Yeah, essentially, like a more accurate autocorrect that's more reliable.
Yeah, there's no reason why we couldn't do that. It's not in there. It's not in our plugins right now, but it should be really easy to do that because Harper already, for every suggestion it generates, it provides kind of a confidence score. So we could totally just rewind the tape, look at all the suggestions that have a confidence score above like 90% or something, and just fix them automatically. I don't see any reason why we couldn't do that. That's a good idea.
That sounds great. Thank you.
You should open an issue on GitHub.
I'll look into that.
Okay.
Thank you.
Okay. I don't know. We're almost at time, but if you have any more questions, please feel free to contact me. Oh, let's do one more question.
I'm not familiar with a lot of the models you're using, but it's very interesting to me. Is there any, in the project, is there any documentation for kind of the reasons and the choices you made in the architecture? Is there a way to dig in so a curious person could understand better?
Yes. So an enormous, so we have kind of two, or at least I have kind of two main places I put documentation. There's the official documentation, and that's on the Harper website. You can read it easy. And that's meant for being like a source of truth. Like this is the current state. But if you're more interested in like a history and like kind of the reasoning why we chose different models, I put all of that on my blog, elijahpotter.dev. I think we post roughly once a week with any important design decisions that were made included in there. So if you're interested in like why we chose a by LSTM instead of something else, or why we're using a Brill tagger instead of something else, that's the place to look. Yeah.
Thank you.
Hi, this is Naho, and I have a question about 5% of the inaccuracy you were talking about. It was 95% accurate, right? Then what's 5% it cannot do? Could you explain to that, please?
Yeah. So the data set we're using right now, and I imagine we're going to change it soon, because that's, like I said, 96 as an ideal is not very good. The data set we're using right now was produced by a number of different sources, different people, and from what I've seen from the project's history, it doesn't have, like they didn't do a great job coordinating quality between those people. So there are slight disagreements between whether or not like a certain adjective is considered part of the nominal phrase. So it's those disagreements that are not necessarily related to like the core of the nominal phrase, which is what we care about, but it's around the edges where it's a little fuzzy. That's where that 4% is getting lost. Yeah. Plus, so that accuracy score is based off of just like if we were to put a mask for each word, is it or is it not a member of a nominal phrase? What we're saying is we correctly identify that Boolean 95% of the time. Yeah. So it's the fuzziness in the mask, and so I'd like to switch it to a data set that is a little bit more strictly defined, if that makes sense. Cool. Well, thank you.